Hey everyone, this is Aarav. Today we are sitting with Pranav from FRNTL, who's the co-founder of the company. And today we'll be learning a little bit more about how robotics is changing everyone's life, how the industry is growing, and we'll get direct feedback and learning experiences from the man himself. So let's just get started. A quick introduction from Pranav would be absolutely amazing.
All right. Thank you very much, Aarav. Thanks for having me here on this podcast today. My name is Pranav Durai, and I am the co-founder and CTO at Frontal. We are an early stage advanced humanoid robotics company over here in Bangalore. So what we're doing is that we're trying to tackle really dangerous and hostile work environments where we think that humans should never be, deployed to work. So we're building humanoid systems for that, so that it's really safe, and also gives a really good ROI for people working in those kind of environments, right? So talking a little bit about my experience, I have close to 6+ years of experience in AI, robotics, computer vision, and also quantum machines. Previously, I was a senior computer vision engineer at OpenCV, one of the very well-known computer vision libraries for robotics. So worked on a lot of projects over there, including small object detection on satellite imagery. I also worked on ADAS systems for autonomous vehicles. So we used like a stereo vision kind of a setup that would help autonomous cars, self-driving cars to navigate through really tight spaces. And I also worked on a little bit of computational pathology, where you have really high resolution images of, tissues of human beings, which you think that, hey, there's some type of cancer over there, right? So we built a lot of solutions for that, right? After that, I joined as a founding team member at a startup over here called 10x. So now they're, I think, rebranded as Origin. But we focused on building autonomous robots for the construction industry. So I was part of the computer vision and perception team over there. But before that, I did my research fellowship from Stanford University School of Medicine, where we built a model that could do a lot of these early detection of cancer on PET CT imaging, right? So it could do organ segmentation and also tumor classification uh, in early stages itself, in PET CT kind of scans that you do, right? Um, but apart from that, I also did a lot of publications on AI, robotics, computer vision, and also quantum machines. Recently, I published a paper called Qubit, which is the world's first quantum vision transformer. So it's like a transformer-based architecture that processes images at scale, and it runs on a quantum classic hybrid architecture, right? But apart from that, I also love to teach. Also been delivering a lot of guest lectures at top institutes over here in India, at IITs and ITs, and also at IIC. Yeah, so that's what I do. Yeah.
Very inspiring, Pranav. Just talking a little bit more about the things you mentioned. Exactly, qubits are one of the most important thing in quantum computing, and I think that's a whole different topic to actually dive deeper into.
Sure.
And yeah, your past is extremely inspiring to a lot of people. Um, how did you come up with the idea of frontal? Saying Earth first and Moon next? What was something that came in your mind and then that led you to coming up with this specific line, this specific phrase?
Yeah. So the goal for me, at least in life, was to help humanity sustain in the future, right? But that's a very broad, big goal that you would have to tackle. But it turns out that you can actually split the goal into multiple sub goals, and then you can achieve the main goal, right? So that is why I strategically chose specific projects in my previous employments as well, right? So accidents are very common when you drive, right? So you need a very safe system that helps human beings on the roads, right? So that is why I, focus on building and developing ADAS systems, right? Cancer is a very big problem. We lose a lot of human lives every year to cancer. So it makes sense to also build something for that. And
Mm.
also another thing is really harsh work environments, right? So think about mining, offshore oil rigs, or any kind of really dangerous work that human beings have to do day in and day out. it actually reduces their lifetime over here on Earth, right? So I for a fact that thought that if I had to do something on my own, I would just pick the most complex thing that ever existed and then build a solution for that,
Mhm.
right? And that is where I actually met my co-founder as well. So Mohit is one of my co-founder at Frontal. We actually met from the previous company where we worked together on different subsystems, but we collaborated very closely on another robot that we built, right? So we said that, hey, we wanted to build really good, rugged humanoid systems for all of these really harsh terrains, right? So I think that is where it actually came from.
Mhm. Okay. Yeah, I mean, definitely making some of the hardest things come with a lot of hard things to look into. And probably the next thing in my mind that actually comes up when I think about what you guys are working on are, I'm pretty sure there must have been a lot of like trial and error. There must have been a couple of times you must have failed in the robotics industry. And like, I just wanted to know what are some of the hardest things you had to work on which failed like multiple times, but then now it's currently working at Frontier.
Yeah, not just frontal, but I'll also talk about some of my previous experiences as well, right? So let's take computer vision and perception per se, right? So we know that it deals with cameras where you use a camera system to, capture an image, and then it passes through some kind of modules, and then you also have an AI model that kind of processes this image and gives you some output. And then based on that output, you do some kind of actuation or manipulation, right? So it turns out that we've built a lot of models in the past for different projects, right? But one of the most complex parts is that the model works really well on a controlled environment, right? Where you know that, hey, these are the few parameters that keeps changing, and these are the few parameters that do not change, right? So it's not a dynamic environment; it's a non-dynamic environment. The model performs really well, right? Even though you have segregated your data set into train and then the test, and you test the model on images which it has not been trained on before, right? It performs really well. But then what we've noticed is that after this model goes into deployment on the actual robot, and then you put this robot into the actual deployment site, it fails there miserably, right? Because there are a lot of parameters that dynamically change during deployment. It can be so we spend a lot of weeks and months trying to figure out, hey, what is the actual problem? Right? Is it the model architecture itself, or is it the data problem? Do we have really less samples for all of the classes that we have in the data set? Or is it some kind of quality problem where we feel that the quality of the image is not that great? Do we have to choose a better sensor to get a higher imaging capability? Or is it some other system that is failing internally, right? But what we've noticed is that there's a lot of other parameters as well, which can come into play, right? So it can either be sensor calibration, right? So cameras natively they have a calibration that you use so that you can position them in some distance from your working site, and then they capture the image. So if it's not calibrated really well on the production line itself, when it goes into deployment, it fails there miserably. It's not on focus or it's pointing somewhere else. There are a lot of problems, right?
Mhm.
Second thing is it's not a single module problem, but on the other hand, it's a multi-module problem, right? The image it actually is captured from the camera, and then what happens is that it passes through multiple modules to get to the last module where the final output comes out. And then you use that for some kind of decision that you take, right? But in between these modules, there can be a lot of failure cases, which we might not even think about,
Mhm.
right? As technologists, we feel that what we built would work really well, right? But we ended up building a lot of visualization tools, which we place like edge cases at these intersections of modules, and then we get derive some kind of data from it. You monitor the outputs at intermediate stages, and then what you do is you take a decision on whether you need more data for this class, where if it's imbalanced or something, or is it just some poor calibration on the sensor, or is it some system level algorithm that is kind of tweaking the output to a point where the other segment is not able to capture it, right? So I think this is a very edge case intensive pipeline. um, you need to have a very deep systems level thinking to design a very highly fault tolerant robotic system. So I think this is something that we did. Yeah.
Yes, yes, absolutely. I completely agree with that. Sim to real is a massive issue in the robotics industry right now. Most of these robotic companies have a huge amount of like runway, but they don't have revenue because the moment their
Yeah.
robot actually goes into the real world, everything is messy. And it's pretty obvious because of the fact that these robots are so used to the environment they're getting tested on, and every single like joint angle, pressure sensors, vision-based models, like vision sensors and everything has been located inside the demo world. And then once they go into the
Mm.
real world, they have no idea how it works out. So, yeah, it definitely is a massive, massive problem. And edge cases are also really important to look into. I know, like, there are different types of ways of collecting robotic data. So, one of them is like egocentric data collection, the other one is teleoperation, and sim to real comes after collecting like a couple of hours of data sets, and then comes in like some sort of coding a robot to actually open and close their fingers. um,
Sure.
so what do you think are some of the best ways of collecting data and storing data, in terms of like embeddings, and how do you think that will potentially help you out come up with better training for the robot in the real world?
Yeah, that's a good question. So it actually depends on a lot of things. Primarily, the platform of robotics that you're going to use to solve that specific problem, right? For example, if you're working in a factory kind of an um, system, right? So there are two types of robotic platforms that you can use. The first thing would be an AMR-based platform where you have like an AMR platform and then it has like wheels, which helps you to navigate through different tight spaces in the factory floor, and then you can use it to transport all of these heavy boxes from point to point, right? And the second thing is if you want to do a lot of pick and place tasks, right? So if there are a lot of packages that are coming in the conveyor belt, and then you'd want to, probably look at it through a camera system and then pick and place these packages, right? It's actually active in warehouses for Amazon, right? Both of these platforms are active in warehouses like Amazon. And then the third thing is you have like a quadruped kind of robot where it's mainly used for surveillance or transportation of different things and navigation and all of that. And the bipedal platform is getting pretty famous right now with humanoids coming out, right? So I think the data collection pipeline has to be derived from the platform and the task that the platform has been intended to do, right?
Mhm.
So if it's an AMR based platform, right? So what are the different parameters that are changing at real time, right? So it's just the wheels at the bottom of the robot, right? So what you'd have to capture there is actually the angle of twist of the wheels. And then the second thing is the speed or the velocity that each of these wheels they spin to do that specific action, right? So if the task is to move the AMR from point A in the warehouse to point B in the warehouse, what is the most maybe efficient path that it can take to go from point A to point B? And during that journey, what are the different manipulations it has to do in terms of moving the wheels at the bottom, at what velocity, at what turns in the path that would take you from point A to point B efficiently, right? So that is how you frame the problem statement, right? So
Mhm.
now what you do is you keep all of these constraints on top, and now you start recording the encoders, right? So you have encoders on all the wheels in the AMR. You just write a top level software stack script that listens to the encoders, which are placed in all of these fields in the AMR platform. And then in the end, what you can do is you can create a structured data out of it, right?
Mhm.
So that is just one example of an uh, AMR based platform. But for mostly for pick and place, what you'd have to do is you would have like a 6 or 8 DOF robotic arm,
Yeah.
right? And then you also have some vision feedback that is coming either from the top or from the side of the
Mhm.
conveyor belt, right? So at this point, what you'd have to do is like if you have two arms to do that task, maybe what you do is you start with arm one, and then you control and manipulate the entire arm to go and pick up that object, right? And also you know which object you're picking up because you're getting that feedback from the camera, which is placed on top,
Yeah.
right? So that grounding is naturally there in the data itself, right? So how would you manipulate your arm to maybe pick up this AirPods case, right? It's slightly placed here. Or maybe if you have a glass, how would you use that to pick up a glass over here, right? So you know that the grasping that you use would be slightly different to hold these objects. And then during that time, what you do is you also record the joint states of each joint in both of your arms, right? So in this case, what you get is a very structured, high quality, rich data set of both the image and also the joint embeddings, which can be passed into some kind of encoder,
Mhm.
deep learning encoder, where you generate the embeddings. And then the embeddings can be used to train any type of deep learning model that you have internally, whether it's a open source model or a custom model that you're building. Yeah.
Yeah, yeah. Yeah, there are a lot of open source models like the OpenX embodiment, which has a lot of data sets, labeled data sets from which you can,
Yeah.
start running the robot. Um, I know like the vision sensing and all has been going on for a huge amount of time, for, a
Mm.
couple of years now. And now there's this sort of new trend of bringing in tactile sensors into like a collaboration between like vision state sensors. What are your opinions on tactile sensors? Do you think it's hard to implement? Because obviously tactile sensor doesn't just mean touch, it means a lot of
Yeah.
um,
Yeah.
things as
For
well.
sure.
So I just wanted to know what you think about tactile sensors.
No, it actually makes sense because even if you see how human beings, we as human beings learn new things, it's not just that we just look at something and we know what to do with it, right? Or it's not like someone tells you about something and we naturally develop a capability to do that, right? Um, a lot of things happen when we touch and feel the things that we use to do some task, right? For example, if you're operating a tool, an industrial tool, you know how it looks, but maybe it's really heavy, right? So only when you pick it up, you realize that hey, this is actually heavy, right?
Mhm.
And when you do repetitive tasks with it, right, you also know that it requires a lot of stress to kind of actually do that task, right? So what I'm trying to say is that human beings not just see and learn, but they also feel and learn,
Mhm.
right?
Yeah.
So tactile sensors naturally take us towards that direction. It kind of gives the deep learning model the ability to feel different objects by not just looking at it, but also feeling
Yeah.
how that object feels on the manipulator, on the end effector, right? And in humanoid robots, the end effector is a wrist, right? So you have a five-finger wrist with a palm and then all the five fingers, right? So most of the robotics companies right now, what they use for humanoid robotics specifically is that they add tactile arrays over here on
Yeah.
the smaller parts of the wrist, right? So you'd add tactile sensors on the on the top of the wrist,
Mhm.
on the fingers, right? So these are like sheet kind of arrays which can be placed on the fingers, right? And then what you do is now you get like a matrix kind of an output
Mhm.
out of this tactile sensor, right? Very similar to how we process images, right? So images are nothing but two-dimensional matrices, right? And then we have multiple channels in an image, RGB, so red, green, and blue, right? Similarly, you have like a matrix kind of a representation for the tactile sensors.
Mhm.
And then when you hold or touch an object, if the encoder comes in contact with any part of that object, then that encoder it fires up,
Yeah.
right? So naturally, if you have 0, 0, 0, 0, if it's a zero matrix, all of the elements which come in contact with the object, those encoders would light up.
Yeah.
And then on the matrix, you would actually see that change, right?
Mhm.
And then you also have a range, right? So it's not like just 0 or 1, but there's a different pressure sensitive, force feedback that we use to hold different objects, right? So
Yeah.
the values would kind of, mirror that behavior.
Yeah.
So now what you do is you just add this as like tertiary or a secondary input to the data set that you already have, which already has vision and then the manipulation joint action states.
Mhm.
And that gives you a rich understanding of how to grasp an object. But I think tactile sensing would be really good if people, adopt it the right way.
Yeah, yeah. Yeah, that definitely makes a lot of sense about the matrix building and different ways of actually collecting data. I think most of like basically the entire robotics industry is moving towards
Yeah.
that at this point, and I think that's a really good move. Um, right now, I just wanted to like, step back and kind of get back into the basics of what led you to this position? Like, what are some of the robotics softwares you have, first learned, and then some of the hardware things you took into consideration for getting into this sort of industry? Because there are a lot of people who are watching this video
Yeah.
and trying to understand how to dive deeper into robotics. So, yeah, what do you think about it?
Yeah, so for at least for me, it starts from a very early stage in my life. So I started coding at the age of 8, right? So the first language that I learned was a programming language called Basic.
Mhm.
We used to write a lot of lines of code and then build basic problems, right? And I was always curious because my first favorite toy as a kid was a floppy disk. So I used to play around with all of these legacy systems at home, and then that actually gave me like a path to see what is capable, right? Someone used to they told that you couldn't use a cursor input on programs that you write using BASIC,
Mhm.
but then in a couple of months, I wrote a script that could actually support cursor inputs on basic 8-bit 8-bit programs, right? But I've always been really curious, even as a kid, right? So there are a lot of electronic devices at home, gadgets at home, even electrical appliances. Instead of thinking about what I can do with this or how can this help in my daily day use, I used to think that, hey, what is inside this machine that is making it do what it does, right? So what I used to do is I used to rip apart old electronics at home, either like used laptops or old desktop computers that we might have, a lot of different appliances at home which never worked. I've ripped them apart, try to understand what are these things. Even if I didn't know a lot of these things, it was really curious for me to understand how all of these things work. But after some time, what I also started doing is that I started writing kernels for operating systems, right? So Android was really famous back in the day,
Mhm.
and because it was really affordable for students like us to buy and play around with it. So what we did was Android 5 was just coming out, and then since it was open source, what we did was so I had an MI phone from Xiaomi. It was like 6,000 rupees INR. And then what we did was we ported Android 5.0 on that phone before Nexus got an update, the official update for 5.0,
Yeah.
right? Um, and then we also wrote a lot of kernels to support that kind of a heavy operating system on that front, right? So since it was like a hardware kind of optimization that you have to do, you have multiple cores on your SoC. So we built a kernel that could do low level and high level context switch. So if you have a very compute intensive load, it would use all the cores on the CPU and then do that task. But if the phone is completely idle and it's not doing anything, it would just switch to one single core and then use a very low power state
Yeah.
to do the compute, right? So what I'm trying to say from this experience is that I got a lot of systems level understanding at a very early stage in my life, right? It's not just writing code for maybe computer vision or perception which is my expertise right now, or robotics, but taking a really large problem, splitting it into multiple smaller problems, and then designing smaller individual systems that can handle all of these things together at the same time. right?
Mhm.
So through this, what I've understood is that it's not just a software experience, but I've also understood embedded systems. So what I can do is I can also create a lot of power distribution circuits. I can design PCBs. I can write firmware that can run on all of these microcontrollers that you use to control these actuators. And then also write top level software code on the top, which kind of talks to multiple levels of the substack, right? So from the software layer to the firmware to the embedded layer to the power distribution, right? So I feel that if someone is doing something like this, it only makes sense that you understand the whole stack, and then have a specific expertise in that you could be really good at, right? Because this is completely interdisciplinary, right? You'd have to look into multiple systems so that you can build one system really well.
Mhm.
Um, but I think, yeah, that should be it. Yeah.
Okay, okay. Yeah, I mean, with the evolution of how internet came in before and now it's the AI world,
Yeah.
obviously, Claude Code, OpenAI, and all of these companies are coming up with absolute amazing ways of writing code without having to touch your monitor. What do you think would be some of the best skills to learn right now? I know like hardware is slightly harder to have hands-on for most of the people, but at the same time, software is almost pretty much getting replaced. So, what are some of the skills on like the hardware side you think would be the best way to actually move into the robotics industry? Like sensor knowledge and like some tools which are important for hardware and or what type of like mechanical systems should you know and like what detailed idea you should have of like mechanical systems. What do you think would be the best way so that you're directly having a path towards robotics?
Yeah. Yeah, I think at least as a beginner in 2026, it only makes sense that the first thing is to understand the theory of robotics. That includes all types of fundamentals, right? So including kinematics, be it inverse or forward kinematics, and then the different navigation algorithms that you can use
Mhm.
to move your robot from point A to point B, different manipulation strategies, basics of perception and computer vision. Um, right? So these are the main things that you'd have to look at. But if you zoom out, there are a lot of things that are still something that you'd have to look at, right?
Mhm.
So if you want to do really good mechanical stuff, design structures, design the actual parts that go into the robot, I would still recommend learning CAD, right? So that is something that you would still learn as part of your course if you're enrolled in a course in a university. But then also you'd have to build a lot of your own personal projects where you use that knowledge and actually build something new out of your class, right? Because if you think about it, everyone in the class is building the same thing
Yeah.
that is being taught, right? But how can you be different from them, right? So that's the motivation. I think that is one thing. And then the second thing is in terms of mechanical itself, how can you package a lot of elements into a very tight box,
Yeah.
right? That is still a very big problem, right? You can build a smartphone that has the state-of-the-art tech, but it would look really fat and thick and heavy. But then how can you still put a state of the art internals into a very thin form factor that a lot of people use, right?
Mhm.
So the same thought process goes for robotics as well, right? So you don't want your robot to be really chunky, especially if you wanted to navigate through really tight spaces, right? You need to have that kind of understanding. Second thing is for electronics, that includes microcontrollers, SoCs, and also firmware, right? I think at this place you start very slow, and you first look at how different products are engineered, right? You don't start engineering your own products.
Mhm.
Um, at least from my experience, what I would tell is that try to open a lot of gadgets that you have in your house,
Yeah.
right? If there's an old smartphone that is in front of you, open it. If there is an old computer system that you have, open it. If you have any hard disks, open it, right? So you understand a lot of these things, how things are packaged, how all of these PCBs are designed, and the PCB layout are also very complex, right? So in the PCB, where do you place all of these components so that they can communicate very freely with each other?
Yeah.
Is there any kind of EMF that is interfering during the communications? And then how's the power distribution like, right? So, so I think this is one thing that you'd have to focus on. And that is only after that you would focus on building something on your own, where you try to have some of these components at home, maybe a breadboard and a microcontroller that you can play around with, a couple of these sensors, try to read values from them and then write values to a subsystem that uses those values to do something, right? So I
Mm.
think that entire pipeline of going from, hey, how are these things actually built, to if I'm doing something on my own, how would I split this into subsystems,
Yeah.
and then actually make it work? So I think that would be for embedded systems. And then the last part is the software stack that actually controls the whole robotic system, right?
Mhm. Mhm.
I think ROS2 has been there for a very long time now.
Yeah.
Most of the companies, robotics companies, they still use ROS2 as their internal software stack. So
Mhm.
the idea here is to master OOPS as much as possible. So object-oriented programming.
Yeah.
If you write procedural code, uh, your robot is going to be really slow. It wouldn't interact or react really fast to dynamic situations. It would be really slow. So the way you structure your system on ROS2 itself also derives down to the OOPS concepts that you use to build reusable modules,
Mhm.
which you can call and then use it, right? And
Yeah.
the top level is the last foundational model or AI model that you use for doing a lot of these things. Maybe you're still using a VLA model, which is open source right now. You just fine tune it on some data and then you use it.
Yeah.
Or what you have is individual modules for each capability for perception, navigation, manipulation.
Mhm.
So over there, latency is a very big problem because if you're running really large models on the edge on the robot, you need to make sure that the compute footprint of those models are very small.
Mhm.
So I think this is how it's kind of
Yeah.
spanned around. Yeah,
Yeah, no, that was a great breakdown. I think it's important to understand the entire scope before actually diving into the robotics industry. And
yeah.
yeah, I was just, this was running through my mind. You have been in this robotics industry for quite some time and you have seen how the industry has grown. My next question is more so related to what do you think is like the future of robotics? Like 5 to 10 years down the line, are robotic systems going to be more edge case towards blue collar jobs, or is it going to be more towards automation, or will simulation become a whole full-fledged thing where like people are not even testing the robot, it's just through simulation? What do you think about this? Like what's going to happen down like 5 to 10 years down the line?
I think different companies have different mindsets where they really want to deploy their robots. On one side, they have a lot of specialized robotic solutions which are built for a specific capability, right? I think we discussed something about warehouse automation where you have AMRs and then pick and place robots. And then the second thing is you also have a lot of general purpose robotics companies that are coming out right now, right? So you have Figure 03, the humanoid robot from Figure, and also you have 1X Neo, Gamma from 1X that
Yeah.
are building general purpose humanoids, right? So these are humanoids that they claim can do anything and everything. But as of now, I think mostly they are deployed in household situations where either you see Figure 03 washing your clothes or holding your clothes or maybe mopping your floor. And then 1X Neo Gamma is kind of like a companion that you have in your home.
Yeah.
It both interacts and then does all of these tasks for you, right? But at least how I feel about this is that all of these robotic systems are cutting edge and bleeding edge. If they were being used to do menial tasks, it doesn't make any sense to have cutting edge, bleeding edge hardware and tech that is running the robot, right? So it needs to make some kind of sense where there is justification for both the tech that goes inside, which is driving the robot to do that task, and also where it's been deployed, like what kind of tasks they're actually doing, what kind of ROI are you getting?
Mhm.
And then the last thing is it actually impacting human lives or not? right? So you can't be just lazy, not do your daily chores, and then
Yeah.
offload it to a humanoid robot, and then it comes and does it for you, right?
Yeah.
So that is one thing. But at least what I see is that in the future there will be many robotic platforms that are more dynamic, right? So think of it like an AMR based robotic platform, but it has multiple arms on the top, right? So it cannot just move from point A to point B in maybe a factory floor, but it can also do manipulation um, after going to different after visiting all of those different points
Yeah.
in the factory floor, right? And humanoids would be primarily used for specific tasks because if the industry or if the market is not that mature for household task automation,
Mhm.
um, and the price point and the timing and all of these things, if it doesn't go really well, then I would still say that humanoids would still be built for specific tasks.
Yeah.
But I think that is how I see this. Yeah,
Yeah, yeah. Recently, I've been seeing quite a few like startups which are coming up who are working more towards blue collar jobs like construction sites where it's like, unwanted
yeah,
situations where people have to be.
yeah,
Then
yeah,
also, agriculture is becoming a massive problem where
mm,
um, people in the agriculture industry, like the first thing they do every morning is go look at their crops. And if there's a robot who
that's
can
right.
inspect all of this, would
Yeah,
also be really nice. So yeah, I
yeah,
mean, when I was going through it, I kind of understood like the future is now more of like how do we actually get these robots to be deployed in the places where it is needed for help? Because
for
um,
sure.
companies like Figure, 1X and all, they sound really cool. They are also really, really good. But it's more of
No
like,
doubts.
yeah, but I mean, it's like it's gonna be at home. And like you go to the
Yeah,
office, you come back, you'll have a clean house, but that's the only thing. Maybe in the future they might scope it out to something even
yeah,
big. So yeah, really, really interesting. One last question before we end this podcast was if you as a founder were to give some sort of tips to, new audience who are trying to get into the robotics industry, what are some of the things you should keep in mind, and what are some of the things you should be enthusiastic about before getting into the robotics industry? And what are some of the best ways to navigate out of problems you face in this industry?
yeah. So at least in the early stage of my career, I was really focused on deep technology. So I took up computer vision and then perception and went really deep into it, right? So be it the data or the models or also the entire system that kind of controls this entire pipeline. So I went really deep into the research and development part of it, right? But now today, if you ask me, if you ask like a founder version of me, right, I would still say that that experience also helped, but on the whole, there are a lot of other things that you'd also have to focus on, right? So raising capital is one thing, right? So you have an idea in your mind, and then you know for a fact that you are capable enough of building it. But then the right people also needs to trust you and put in money so that you can raise that amount of capital to actually do that, right? So that is one thing. Second thing is how do you manage all of these teams, right? So you have a lot of teams that are working in your company, and then it's completely interdisciplinary. So there can be a lot of miscommunication between teams, and there needs to be a really good tight integration cycles where all of the teams come together and they build the whole thing, and then you actually start seeing progress. Sorry, and there are a lot of these other things that also go into picture, right? But if you know for a fact that hey, this is what you want to do and this is exactly what you want in your life, you would definitely find a way to achieve it, right? So there are three things, right? So the first thing is hard work. So you need to work really hard towards your goal. So if you have a goal in life, you'd work really hard towards it. Second thing is consistency, right? So even if you think that you're putting in hard work, but it's in different bursts of efforts that you're putting in, it won't compound to a very big percentage at the end, right? So if it's like 3 hours today, then it should be 3 hours tomorrow, 3 hours the after tomorrow. That consistency should be there. And the last thing is perseverance, right? So during this process, when you're putting in hard work and then you're also consistent, a lot of things can go wrong, right? A lot of people can come and pull you down. They can come and say that, hey, what you're doing is wrong. Or maybe you should not do that, right? So there are a lot of things that can come into picture while you're really working hard and then you're also consistent. But
Mhm.
you need to ignore all of that and still keep going, right?
Yeah.
So I would always say that hard work, consistency, and perseverance. So those are the three main things that you would have to focus on. But as an individual advice, I would still say that build a lot of personal projects, right? So um, look at the world, go around, talk to people, try to understand what are different problems that they're trying to face on a daily life, right? Be it a very old person or someone who's working in a deep tech startup, or maybe someone from the research industry. Speak
Yeah.
to different people. They have different perspectives in what they want and what they don't want. And second thing is, with whatever skills and knowledge you have, try to build a solution for that.
Yeah.
Right? Try to pick the problem that kind of interests you and try to build a solution for that. And now this will help you because you're not just trying to replicate a project that you find online, or maybe a friend told you about it, or maybe there's a video on YouTube, right? You're just following a tutorial to build it. But in this, you're actually taking a problem, uh, splitting it, trying to solve it, designing a system for it. You're going through the entire cycle from hardware to software to testing it, and then actually seeing if it actually solves that problem or not, right?
Yeah.
Maybe it works out. You can even monetize it in the end, or maybe build an entire startup around it. Who knows?
Yeah.
Anything work, anything can happen. So I think these are the three main things you would have to focus on if you're starting out fresh out of college, or you just started college probably, or
Yeah.
maybe even after 3 years of your career, right? But yeah, yeah,
Thank you. Thank you so much, Pranav. That was really good, insightful conversation. And I'm sure everyone, whoever is listening to this podcast, is definitely going to have a good time understanding how to navigate in this industry and what are some of the things from the perspective of a founder to look into and what are something really important to go through. So thank you so much, Pranav. I hope we get to talk again soon and then maybe we can catch up and have a better conversation in the future, just learn more about where has Frontal reached at that point, how well it is growing, and definitely have an opportunity to meet in person and collaborate sometime in the future. So thank you so
yeah.
much, Pranav.
Yeah, thank you very much. Thank you for having me in your podcast. And then I wish you all the very best for your career. Yeah, take care.
Thank you.